All right. Hello, everyone. Sorry about that. They're still tweaking the audio a little bit. We're running a little bit late, so I'm going to get started. My name is Aria Stewart. I work for this little company that you may not have heard of called NPM. I actually say that because a few people don't realize that NPM is an actual company that runs the NPM registry, hosting those 300,000 and counting Node modules. But I'm not going to talk about NPM today. I'm going to talk about a particular kind of modularity, a particular way of writing software that I think is powerful, and I'm going to try and bring a few new ideas to how we break up software projects, and I think that actually is going to affect how we interact and talk with each other as well. I'm going to go beyond the philosophy of small modules a little bit and get into the philosophy of modularization in general. So first off, I want to ask you, what is a module? I'm going to spend a little bit of time on this one because it's kind of an everyday word in our industry. It's not often a word that we hear defined. I want you to think about what it means to make software modular. This is the simplest definition I could come up with. A bit of software that has been an interface defined between it and the rest of the system. There's some implications here. There's a separation between the module and the system. And I'm not saying how far, but the fact that there is a separation between the module and the rest of the system is an important distinguishing feature. And we can talk about the interface, and I'm going to get into that later. And there's a lot of kind of interfaces to software. But the bit that I think is really interesting is the word defined. This means that we've made some decisions regarding this module. Just copying something blindly into a new file doesn't make it a module in anything but on a technicality. Defining something means that there's a bit of intention behind it. Here's a refined definition. A piece of software with a defined interface between and a name that can be shared with others. Because I work for NPM and I've been making open source my entire professional career, I've also got a particular bunch of things that I mean when I say a module. I won't advocate sharing everything because this is a talk on radical modularity, not radical openness. But sharing is an important part. Communicating with others is an important part of modularizing software. And in particular, I want to talk about naming things. When we name a module, when we name something, it takes on a life of its own. It's now an object in its own right. It's got an internal life. This happens when we name a file. It happens when we name a package. A name is the handle that we can grab onto something with mentally, and we can start treating it independently. A defined interface is the first step of that independence. It's the boundary that gives the thing that separation from its internal life and its external life. Things inside a module can get a relationship with that boundary, and things outside of it get a relationship with that boundary, but they don't directly interact. They are now separate. And that boundary, things inside that boundary can be rearranged without affecting the things outside of it, without changing those relationships. Now, not every module gets published or even becomes a package on the registry. We usually push things up to GitHub really early, but source control isn't the same thing as publishing a module for others to consume. Even if they're both just ways to store particular sets of bytes, even just separating things into a separate file, naming it, and that's the naming, and choosing what constitutes the interface to the rest of the system, that counts as modularization. Now, names are powerful. We can commit to names a little bit more firmly when we publish them and give them version numbers. We have actually put a little bit of effort into that. But that's not required. A module can exist just as a file passed around. It can exist as a file inside of a project, not yet given that separate life entirely. Self-sustaining open source projects are kind of an interesting thing here because they have to be bigger than a tiny module. How many of you use any of Substack's modules? Everybody in the room probably does, indirectly. Or how about one of Syndrasaurus's? Those modules, there's no single open source project there, no large open source organization driving those. And so those modules sit with the attention of one or two people who care about a bug in them. If you want to create a self-sustaining open source project, you need a bigger unit. But that doesn't mean that you have to have a monorepo and a giant project with a single masthead. You can have a bunch of tiny projects under an umbrella like Hoodie, which is doing some really exemplary work and breaking out their entire system up into little tiny modules while keeping a cohesive brand and open source project. But the other option is the Substack model, when we make modules so small that they just trend toward done. They're names for a now static piece of code, or a now static, it doesn't even have to be code. Maybe they're just bestowed upon somebody who tidies them up, finishes a few ragged edges, writes a few test cases. Or maybe they're left in a little library box for somebody else to discover when we're not using them anymore. Maybe they're published, maybe they're widely used and loved. Maybe they're just sitting there in the registry for that one person who needs that exact piece of code. Maybe they end up in the scrap heap for our later selves to build something from. Picking a name for a small module is easier than picking a name for a big module, because a small module's name is generally what it does. A name for a big thing takes a lot more magic. Something the open source movement that is not really widely acknowledged is it made a huge ecosystem for the performance of software as a social art. Not only that, but then the explosion of social openness that came with it has created kind of an orthogonal movement to the free software movement. It's not as concerned about copyright law and open engineering, but sharing ideas and techniques. And as a side effect of that, software engineering now includes the practice of software as an art. I practice code as an art in addition to engineering. That means that quite often I'm trying to make a statement about how the world should be in how I work. A good portion of art is making concepts visible in the land of the abstract. That means making it named. That means giving a thing a name so that you can discuss it and it becomes a thing you can interact with and experience. We can create a module of code only to abandon it later. It's actually okay. Once it's served its purpose, it's okay to let things go. People complain about dead code on the NPM registry, but those are old projects. Quite often they are pieces of old ways of developing. And the historians among us they find a few gems there, old projects. You can actually reconstruct things from the Node.js days, and they still work if you get the right runtime. We have to respect the tension, though, between art and engineering. Sometimes we do things to show instability or to test a limit. We see this too with people who publish security exploits as a module. It is possible to do damage both culturally and technically with what we create. And sometimes we just simply create to delight each other and to play with the fashions of the day. One of the interesting differences between software artifacts as a medium of art contrasted with all of the other kinds of art is that despite working in a very definite medium, bits are absolute. What we make is never finished. It exists in our culture, and software creation is totally a culture. It's a culture of its own, and as web workers in particular, working as artists, a lot of what we create straddles the lines of engineering, fine art, performance art, and craft. And so it goes, even the biggest pieces of software are made up of smaller parts. It's the natural way to approach problems. You take a problem and you break it down. A large module is nothing more than a collective name for a bunch of little modules that are trying to get out of it. Modules that may not have their final names and their final forms. I like small modules as the norm because I like to think in terms of named things. I'm happy living in the kingdom of nouns. But more than that, I'm happy to abandon a thing when it no longer suits me, and it's much easier to get rid of a small module than a large one. There's some great advice an article going around the internet currently called Make Code Easy to Delete, write deletable code. And I think that's a powerful concept. But what I want to ask today is, what happens when you make everything a module? What happens when you break off all of the pieces that you can and publish them where that's appropriate and share those names and let others wield the power of those pieces of code? What does this do to our culture as programmers? Now I'm going to get practical for a moment. I talk about NPM a lot, but this can actually be extended. Breaking things into node modules is not the only way to modularize software. APIs can be modular, component systems, even design can be modular. Start trying to think in modules, what is the boundaries between these things? But when I started at NPM, we had a monolith of old CSS built up, the kind of growth by accretion that you get during most web software projects, especially during a hurried startup. We had a lot of styles that weren't positive, were unused, and a lot of pieces and parts that depended upon each other. Since then, and with a huge shout out to Nicole Sullivan and her huge body of work on this, seriously, go watch her talk. Our best practices are killing us if you work with CSS. We started tearing apart the site and rebuilding it, and we actually modularize our CSS. We break it out into actual separate node modules. And these modules have defined interfaces between each other. This piece provides this kind of a class. This piece requires this other kind of class to be present. The API surface of CSS is the HTML it requires. And all of these modules ended up having names. We published them under the as scoped packages on the NPM registry. So we have 30 or 40 CSS modules that we download and build our CSS out of. We're using a tool called Dr. Frankenstyle. It's a pretty simple module that just scans through your node modules folder and concatenates all of the pieces in dependency order when it finds styles in them. It's kind of an inelegant tool, but it works pretty well for us. And we've actually annotated those dependencies into the CSS. So the tables module requires the basic styles module. The dialog boxes component requires the rest. And we started being able to grapple these things individually. We can actually identify when these modules go unused because they're small enough and achievable pieces that we can say, we aren't using that piece anymore, and we actually have something to refer to, rather than lines 97 through 336 and 1200 onward are unused. That's a much easier way to deal with things. There's another tool called PostCSS Import that lets you extend the import statements in CSS into use the node module system. And that's actually really powerful. I think I like this approach a little bit better than the one we're using. So we may abandon Dr. Frankenstyle at some point and switch over. Both of these systems do one really interesting thing, is that they follow local references inside the modules that are published. And so you can actually include assets in these packages. So when we install CSS that require image files, those image files get moved into our final build folders along with it, so that we can, and the references adjusted so that those stay valid in another context. That's super powerful now because we can actually get those images and that dependency between those pieces abstracted away, and they become part of the module and not part of our day-to-day interactions with it. And we don't have to think quite so hard about what's required to run this particular piece of code. And by reducing that API surface area, we've made things more reliable as we're developing. Now, CSS has pitfalls. It's still a single global browser namespace, a single heap of rules to apply, and it's not a clean interface. There is nobody who would argue that CSS is a clean interface between it and the rest of the system. So this doesn't solve all of the problems, but it has made things a lot more tractable. But what happens if we extend this into other file formats? SVG files can have local references. They don't actually work everywhere because there's security concerns and a lot of unimplemented features in browsers where it won't chase these references because nobody has done the work to make sure that they're secure in the context they would be executed. So there's a lot of missing features. But we can use pre-processing tools too. So what if we were to break up large animations into small modules, a single sprite here, a single sprite there, and include them by local reference, and then build up a larger and larger system here? What is the interface to an SVG file? The text of it, the parsed HTML, just the file name? At NPM, we actually use our icons. We actually post-process icon files into we can both inline them into the HTML and do a lot of caching so that we are no longer using CSS fonts for this. Now, we don't just build raw HTML anymore. We use templating systems to break our HTML apart. We've already learned to modularize HTML. But in the process of reworking the NPM website, we had components whose CSS was the interface to that was the HTML you had to create, and that's a fragile interface. Every time we changed what HTML was required to instantiate the component, that component required a major breaking change, and we had to update all of the callers of that, all of the users of that module. If by putting the templates inside of a module, we can now move that boundary inside that system, and now the caller just calls a single, in our case, it's a handlebars template. And by calling just the template as if that's the defined interface, we don't have to think about the specifics combining the CSS and the template. So this is our HTML interface, and that converts into that simple handler call. In that case, loading a template from a package. You'll remember that I mentioned SVG icons. It turns out that inlining small icons is one of the most efficient ways to use them, but it doesn't scale very well in the development process if you're actually manually inlining. The alternatives, icon fonts, are really kind of brittle. You have to do a lot of hacking to make it work with all of the different runtimes. So what icons have to be in large groups if you do it that way. But by moving things into the module system, we were able to do that and inline them automatically. And then there's something that happened in our ecosystem. How many of you feel like React is something that just happened to you? Like it just came up out of nowhere? Okay, there's a few. React, there's a reason that React talks have been really popular for the last couple of years. It really did make a radical shift in how we design web frameworks. It was a very provocative module. But more importantly than all of the functional programming and things that it has brought, it actually brought a lot of talk about modularity. It did this covertly. Nobody ever thought to say, we want React because we want modules. But what it did was by breaking things out into ES6 components in particular, we now have people publishing React components on the registry in quite a large number. And they have a rich interface. There's a programmatic interface now to HTML that is flexible enough that we can find a durable interface. We are no longer including brittle templates. And so a lot of people are starting to experiment with new kinds of modularity, particularly on the web, but it has spawned a whole bunch of new kinds of talk. It also, so if you're a React programmer, that from package helper on my slide about handlebars probably looks like a strange version of including a component. The concept's the same. We've created a module boundary, and we're actually exploiting modularity to build our systems better. So what can we steal from React? Modularity and the clear boundaries on interfaces has changed a whole ton. Let's rethink how we integrate things and have an interface that's simple and clean. There's been a lot of experiments, too, on having React components that do their own CSS or they namespace the CSS they require, which helps fix the single namespace problems of having CSS in the browser. And then the React component generates HTML that refers to a namespace CSS, not the original source form. So you're editing with simple names that humans understand, but what runs in the system is namespaced and much more durable and won't collide when modules are combined. By moving that boundary from that raw CSS into a call to a React component, it made things a lot more reliable. And how radically can we change the complexity of an API by changing the kind of thing that we export? I want to talk about what else can be a module. At PayPal, I did work to make translations a loadable thing, which leads rapidly into separating those pieces into entirely separate modules and packages on their own. Modules are powerful because they actually form nice divisions between people. One team can create one module and another team can create another, and as long as there's a communication about the boundary, it gives both the freedom to innovate within their space without having to consult the other teams. And this led to a lot of folks at PayPal doing a lot of interesting internationalization work, breaking the files up separately and having separate life cycles and separate workflows and referring to them by name. We were able to scale up that process and simplify how much we worked on it. So what else can be a module? Language files, entire websites, license texts, JSON schemas, shared test suites, lists of legal terms. We can even make modules that are nothing but known good configurations of other modules combined and tested. But that last one on the list is really interesting. Kyle Mitchell is a lawyer. He does a little bit of work for NPM. But he uses a lot of software in his work to draft legal texts. And in so doing, he's published a lot of tiny modules on the registry. Mostly they're JSON files. A module can be as simple as just a JSON file. But they are cleanly licensed and well-versioned pieces of legal language. that he uses to build up contracts and to fill forms. And he's using tested, tried phrasings and storing them in a place that he and others can refer to. Sounds kind of familiar in like software development, right? Text itself can be a module with an interface, even if that interface is just that you're going to have to take this bit of text and concatenate it to make sentences. But now I can actually show you how to make a modular system, how to exploit the Node resolver algorithm to build something that gives you this kind of power that we've got from Node modules and take it to other languages and other contexts. The underappreciated feature of Node modules is that they nest. This really bugged the Windows users back with NPM 2, and you ended up with those really deep paths that you couldn't delete. Now NPM 3 has unnested them a little bit, and that helped a bunch. But because of that, we spend less time wrangling the related paths between things, and we can just refer to them by name. And if something requires a module, it's going to get the right version that it needs. There's a module, a Substacks resolve module, which will look up a file and a package. It doesn't matter where that package is relative to the calling code. It does the work needed for that. This will look up the bologna SVG file in the Mad Science Lunch and Meats package. And it'll find it no matter where it got in the tree. And that's our primitive building block when we're building a modular system. There's another thing that's common to do. You add a field to package JSON that for a different kind of file. Dr. Frankenstein looks at the style property rather than the main property in the package JSON. So now a package can be two kinds of module at once. It can be both JavaScript code and it can include the related CSS all in one package. So we can actually make some guarantees in our module loader that the dependencies will be isolated, that they'll be deduplicated as much as possible, that local paths are relative to the file, that's the important one if we can, and that there's a single entry point. I love that each module refers to things by local paths, because that means that you no longer have to be aware of the global namespace when you're building a module. You can focus on the task at hand. A lot of people fought this. They wanted a project-wide include or require from the project root in Node, because it would simplify moving code around in a project, but I think it makes things more fragile in the way that they develop. So I keep building similar models. I build them out of Substacks resolver and shoehorning it into whatever language I'm working with, be it templating or SVG. And these tend to be very short modules that will just do the work to assemble them and find the local pieces. But then if everything's a module, what can we do with that? We have simplified things enough to start giving our programs a vocabulary to start extending themselves. We're starting to talk about building software not as developers, but even as users out of modules. We already see this in the Atom editor, using packages stored in the NPM registry, and we're seeing this in Hyperterm, an entire terminal editor or terminal window built out on Node technologies, and with the extensions are published as modules on the registry. Can modules be remotely, or even remotely loaded packages be first-class objects in our system that we refer to in our programs? Or what about generating new modules as a user builds and works on their own system, and they themselves can publish their extensions? What kind of interfaces can we give? Web services. How do we apply modularity in web services? Data sets with guarantees about how they'll develop in the future. There's other kinds of modules here. And how radically can we simplify the interface of something so that it has some longevity? One of the most influential concepts in my career was the phrase that a lot of us have heard about Unix, that everything's a file. That's a lie. But there's a lot of things in Unix that aren't files, IPC and system calls and locks. But the key concept there is that with a very tiny primitive, if everything is a file or a pipe, that is a durable interface that's going to last a long time. Password files, all of these interfaces are radically simple. A text file delimited by colons and new lines, line delimited log entries, or just a plain file, it's a sequence of bytes. You don't have to care about the interface to it. Those interfaces are durable and they last forever. System calls have not changed a lot in 40 years because they were done right in the first place or done very close to right, and they've become very, very durable. I love to pick on Unix because it's got so much ancient cruft in there, but it's really one of the elegant systems. Another radically simple technique for modularizing came from the rack web server library for Ruby. It reduced the interactions between a back-end web framework and the web server to a single function call. Environment variables in, a status code, a body out. And by reducing it to that single function call, it took off very, very popularly, and now all of the Ruby web servers use rack. Node streams, they're a very generic primitive, and so we've seen thousands and thousands and thousands of modules because it has a generic and relatively simple interface. But I hope you learned something today, and I hope you're inspired to think about things differently. Thank you.